Review exercise number 1. The question is to find the value of x. Okay, we have isosceles triangle, angle ABD, and we have equilateral triangle, angle BCD or BDC, right? So all three sides are equal, all three angles are equal in an equilateral triangle, right? So this must be equal to 60, 60, 60, right? If this is a 60, we know that this angle right here is 120, right? Because it's a straight line. Sum of these two angles must be equal to 180, right? Now, this is isosceles triangle. If this is one base angle x, this must be another base angle x, right? So x here. So we know that sum of three angles in a triangle must be equal to 180, right? So x plus 120 must be equal to 180. So 2x plus 120 is equal to 180 minus subtract 120 each side. So that's going to be 2x is equal to 60. So x is equal to 30, right? Number 2, we have two isosceles triangles, ABD and BCD, right? So this side right here, this side, they are equal to each other. They're congruent. Then these two base angles, angle C and angle DBC, this angle right here, they are congruent, right? Base angles. So this must be 70. If this is 70, we know that this one is equal to 110, right? Because the sum of these two angles has to be 180. And this is, again, isosceles triangle. Base angle right here, base angle right here, right? So if this is x, this is also x. So sum of these three angles in triangle ABD must be equal to 180, right? So 110 plus x must be equal to 180. So 110 plus 2x is equal to 180. Subtract 110 each side. So we have 2x is equal to 70 and divide each side by 2 gives us x is equal to 35. Number 2, given side AB is parallel to side CD and the side BC is parallel to side AD, the question is to prove that triangle ABD is congruent to triangle CDB, right? So we're going to write 2-column proofs. Always start with a given. So number 1, we have AB is parallel to CD and BC is parallel to AD. The reason, that's given. Always start with a given. Number 2, if these two sides are parallel, then this angle right here and this angle right here, they are congruent, right? Because they are alternate interior angles. Do you guys see that? These two, let me draw extended side. These two lines or sides are parallel. Then these two angles are alternate interior angles, right? So I can write angle CDB first, CBD, okay? Angle CDB is congruent angle ABD, right? Angle CBD, angle ABD. They are congruent. Reason, because they are alternate interior angles. Alternate interior angles are congruent, right? Okay, number 3, we also have these two sides, right? This side right here, BC. BC is also parallel to AD. Then look at this red line. This angle right here, angle CBD, is congruent to angle ADB, right? This angle right here, this angle right here, they are congruent, right? Just like these two sides are parallel and this is like a transversal, then these two angles are alternate interior angles, right? When two sides are parallel, alternate interior angles are always congruent, right? So we can write angle CBD is congruent angle ADB. The reason, they're also alternate interior angles are congruent, right? Okay, now when we look at this triangle right here, ABD and CBD, they share this side BD, right? They share this side. So I can write number 4, side BD is congruent to side BD, right? That's reflexive property, right? So number 5, finally, here we have two congruent angles, two pairs of congruent angles, and one side is congruent. So angle, side, angle, angle, side, angle. By ASA, these two triangles are congruent. So we can conclude that triangle ABD is congruent to triangle CDB. The reason, by ASA, right? Angle, side, angle. Angle, side, angle congruence. And we're done. Number 3, in the figure below, choose two of the triangles that must be congruent and state the congruency principle in each case. Here we have a figure, we have 8 triangles, A through H. So let's start with A. A has side 9, angle 40, side 7, right? So that's side angle side, SAS, right? B, we have also side 9, angle 40, side 7, 947, 947. Oh, these two triangles are congruent, right? So here we can say that triangle A is congruent triangle B by SAS congruence, right? So let's look at C now. C, 6, 7, 9. 3 sides are given. So that's S, right? That's S, I'm sorry. So that's going to be S, right? Okay, here, if we look at triangle E, that's also 6, 7, 9, S, right? S. So we can conclude that triangle C is congruent to triangle E by S, right? Good. Now let's look at triangle D. D, we have 2 angles and one side. If 2 angles are given, we can actually find this angle also, right? 180, 180 minus 40 minus 85 is this angle right here. So that's going to be 180 minus, isn't it 125? So that's going to be 55. So this is a 55. So here we have a 40, 55, 85. So if we look at this triangle here, if we look at triangle G, 40, 55, then this must be 85, right? So this is 85. So if we look at these two triangles, D and G, we have 47, 85. Here also 47, 85. These two triangles are congruent by angle, side, angle, right? Angle, side, angle. Same angles, same side. So angle, side, angle, angle, side, angle. So we can conclude that triangle D is congruent to triangle G by angle, side, angle. Right, so far so good? Okay, now let's look at F. Here we have F. Here, 40, 50. That sums to 90, right? Then this must be equal to 90. 40, 50, this one 90, right? Here we have a 50 side 9, 40. 50 side 9, 40, right? These two triangles are congruent by also angle, side, angle, right? So F is congruent to H by angle, side, angle, right? Number 4, the question is to find the value of x, y, and z. We have two triangles, triangle ABC and triangle ADC, right? And the side AB is congruent to side AD, side BC is congruent to side DC, and both of these two triangles share the side AC, right? So by side, 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 right? Side, 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 SSS. By SSS, these two triangles are congruent. So triangle ABC is congruent to triangle ADC by SSS congruence, right? So if two triangles are congruent by CP, CTC, each corresponding angles are also congruent, right? So here, this angle is equal to this angle, right? So x minus 12 is equal to 36. Then x is going to be add 12, then our x is 48, right? Also, these two angles right here, corresponding angles right here, they're congruent, right? So 2y minus 3 is equal to 61. Add 3, that gives us 2y is equal to 64. Divided by 2 gives us y is equal to 32. So far so good? Okay, so angle B right here, corresponding angle, angle D, they are congruent, right? But we don't know what the angle D is. Here we have 2y minus 3, that is equal to 61, right? Because this angle right here, this angle right here, they are congruent, right? Then angle D is 180 minus 36 minus 61, right? So angle D is equal to 180 minus 36 minus 61. So 180 minus, that's 97, right? That's 97. So 180 minus 97, that's 83, right? So this one is 83. So we can write the equation. Since these two angles are congruent, z plus 5 is equal to 83. So z is equal to, okay, minus 5 minus 5 gives us z is equal to 78. So x is 48, y is equal to 32, z is equal to 78. Number 5, given side PQ is congruent to side SR and the side PR is congruent to side SQ, prove that, the first one is we're going to prove triangle PQR is congruent triangle SRQ. So PQR, this triangle, SRQ, this triangle right here. And we're going to write two column proofs. Okay, so always start with the given. Number 1, given is PQ is congruent to SR and PR is congruent to SQ, right? So PQ, SR, they are congruent. PR, this side actually, this side right here is congruent to SQ, this side right here, right? And if we look at this triangle right here, this triangle and this triangle right here, they share the side QR, right? So we can write number 2, side QR is congruent to QR. That's a reflexive property. Okay, number 1 was given. Number 2, reflexive property, right? Then we're done. Number 3, here, two sides are congruent, and also third side, they share it. So they are congruent, right? So side, 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 side. We have 3 pairs of congruent side, right? So we can say these two triangles, triangle PQR is congruent triangle SRQ by SSS congruence. Easy? Number 2, this time we're going to prove triangle PSQ. PSQ is congruent to triangle SPR. SPR, this triangle right here. So this was given. So I'm going to start with the given, right? So when we look at this triangle, PSQ and SPR, both of these two triangles share the side PS, right? So I'm going to write number 2, PS is congruent to PS. That's a reflexive property. Reflexive property, right? So these sides are congruent. This side, they share it, congruent. These sides are congruent. Side, 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 side. So these two triangles are congruent by SSS congruence, right? So we can conclude that number 3, triangle PSSQ is congruent to triangle SPR by SSS congruence. Okay, number 3. Now we're going to prove triangle PQO. PQO, this small triangle, is congruent to triangle SRO. SRO, this small triangle right here. Okay, we already proved that this triangle right here, PQR, is congruent to SRQ, right? We proved, number 1, we proved triangle PQR is congruent to triangle SRQ. That was proved from number 1, right? So if these two triangles are congruent, then by CPCTC, this angle right here, this angle right here, they're congruent, right? So I can write number 2, angle QPR, this angle right here, is congruent angle RSQ, right? RSQ by CPCTC. Congruent parts of congruent triangles are congruent, right? Number 3, we also proved that this triangle right here, is congruent to this triangle right here, right? Look at this, this triangle right here. Then by CPCTC again, we can say that this angle right here and this angle right here, they are also congruent, right? So I'm gonna write triangle PSQ, right? PSQ is congruent to triangle SPR. So PSQ, this triangle and this triangle, right? So by CPCTC, these two angles are congruent. So number 3 was proved from number 2. Number 4, we can say that angle PQS, this angle right here, is congruent to angle SRP. This angle right here by CPCTC, right? Also, it is given that PQ is congruent to SR. It's right here, right? So this side right here, this side right here, they are congruent. Number 5, PQ, oops, that's P, okay? PQ is congruent SR. That was given, right? So look at this two triangle. This triangle right here, this triangle right here, they are congruent by angle, side, angle, angle, side, angle, right? So we can conclude that number 6, triangle PQO is congruent to triangle SRO by angle, side, angle congruence. Review exercise number 6. Given AB is parallel to DE, BC is parallel to EF, and AD is trisected. Trisected means it is divided into 3 equal parts. So AF, FC, CD are equal to each other. So we're going to prove that triangle ABC is congruent to triangle DEF. Okay, let's start with the first given. First given is side AB is parallel to side DE. So this side right here and this side right here, they're parallel. Okay, if we have two parallel sides and transversal right here, then look at this blue line here. Do you guys see that these two angles are congruent? Because they're alternate interior angles, right? So this angle right here, this angle right here, they are equal to each other. So reasons for number one is given. Number two, from this given, we know that angle BAC, angle BAC is congruent to angle ED, let's say EDF. This angle right here, this angle right here. The reasons is alternate interior angles are congruent, right? Okay, number three, we're going to start with another given. Number three, here BC is parallel to side EF, right? So this side right here, BC, is parallel to EF. So if two sides are parallel, then look at this red line right here. If I drew that line like that, do you guys see that these two angles right here, they are congruent. They are alternate interior angles, right? So here we have two sides and this is like a transversal. See? Okay, so number three, reasons for number three is just given. Oops. That's just a given. And from this given, we know that angle, number four, angle BCA, right? BCA is congruent to angle EFD. And that's also alternate interior angles are congruent, right? Okay, here, third given was AD. AD is trisected, divided into three equal parts, right? Then we know that AF right here, FC right here, and CD right here, they are all equal to each other, right? So I'm gonna write side number 5, side FD, AF is congruent to side CD. Reason, because AD is trisected. Right? Okay, number 6. Let me write number 6 right here. We're gonna need some space. I'm gonna add this side to this and this side to this. Okay, so I'm gonna add AF plus FC and CD plus FC. In each side, we added equal side FC, right? So they are congruent. That's addition property, right? We can always add same stuff each side. So number 6, that's addition property. Okay, so look at this. AF plus FC, that is equal to AC, right? CD or DC plus FC, that's equal to DF, right? Or FD, right? This side plus this side is equal to this. this side plus this side is equal to this, right? So instead of this expression right here, we can write number 7, side AC for AF plus FC is congruent to side FD for CD plus FC. That's what? That's a substitution. Instead of this, we substituted this. Instead of this expression right here, we substituted FD. So that's a substitution property, right? Now we can conclude that triangle ABC is congruent to triangle DEF because we have two pairs of congruent angles and one congruent side, right? So by angle, side angle, angle, side angle, we can conclude that these two triangles are congruent by ASA congruence, right? So number 8, triangle ABC is congruent triangle DEF. Reason is ASA congruence, right? Review exercise number 7. Given triangle ABC is equilateral and these three angles are congruent, right? Then we're going to prove these three triangles are congruent. Triangle ADB, this small triangle right here, and triangle BCE, and CAF. And this triangle right here is equilateral, right? So let's start with the equilateral triangle. Number 1, triangle ABC is equilateral. Oops, no space. Okay, right here, equilateral. Okay, reason is just given. Number 1 just given, right? If this triangle is equilateral, we know that all three sides are congruent. All three angles are congruent, right? Let's write number for each angle right here. Let's say this is number 1 angle. This is number 2. This is number 3. This is number 4. This is number 5. Let's say this is number 6 angle. Okay? And number 2. So since triangle ABC is equilateral, we know that side AB is congruent, side BC is congruent, side AC, right? That's definition of equilateral triangle, right? Also, we can write all the angles are congruent. Number 3, all the angle number 2, angle number 3, angle number 5, they're all congruent. They're all equal to 60 degrees, right? This is also definition of equilateral triangle, right? Number 4, here, sum of these two angles right here, number 1 angle, number 2 angle, number 3 angle, number 4 angle, number 5 angle, number 6 angle, they're all equal to 180, right? Definition of a straight angles, right? So we can write number 1 plus number 2, that's 180. Let me just write all 3. Number 3 plus number 4, that's 180. And number 5 plus number 6, that's 180, right? That's just equal to, the reason is definition of straight angles. Okay, so we just know that this angle is 60, this angle is 60, this angle is 60. Then this angle right here, number one angle, that's 120, right? That's 120. This is 120. This is 120, right? So we can write number 5. Angle number 1, this is number 1. Angle number 1 is congruent. Angle number 4 is congruent. Angle number 6. They're all 120, right? If we subtract 60 from 180, right? So that's going to be equal to subtraction property. Subtraction property, right? Number 6. Here we have given angle ABD. So this angle right here, okay? And angle, well, let me write the number for that angle. So we have 1 through 6. That's number 7 angle. Here, number 8. Here, number 9. Okay? So ABD, that's number 7 angle. BCE, that's number 8 angle. CAF, that's number 9 angle. All these 3 angles are congruent. It's given, right? So angle 7 is congruent to angle 8 is congruent to angle 9. This is given. So 6, that's given, right? So finally, look at this triangle. We have angle, side, angle, right? This red angle, side, this is it green? Green angle. Okay. Angle, side, angle, angle, side, angle, right? So these 3 small triangles are congruent by angle, side, angle, right? So number 7, let me write number 7 right here. Number 7 right up here. We don't have space. So triangle ABD is congruent to triangle BCE is congruent to triangle CAF. Reason by ASA congruence. Right?